Now in this session we are going to start with the graph of exponential function. Alright, before that, before starting the question or just plotting the graphs, let me give you an idea how we are going to plot the graph of exponential functions. So here is an example of graph figure, right? Let's suppose we need to sketch y is equals to e to the power x. Alright, so if I draw my axis here, let's suppose that it's my grid, x-axis, y-axis. The graph of y is equals to e to the power x always follows this pattern. It always follows the same pattern, the curves you can see on your screen. It will never ever touch the x-axis, right? So, do you remember the concept of asymptotes we had discussed while we plot the graph of 10x, right? We had discussed the concept of asymptotes while construction the graph of 10x. Asymptotes are such line that this curve here, it can never ever cuts or meet the x-axis. It will always get closer to the x-axis, but never touch the x-axis. That is why in this graph x-axis is my asymptote. Alright, so that is the behavior of y is equals to e to the power x. You can verify it, or you can say that this point here we have the value 1, right? How? We have y is equals to e to the power x. We know that when on y-axis x is 0, right? So when I place the value of x 0, so I will get y is equals to e to the power 0. And any number, any variable with 0 power is equals to 1. So we have a coordinate that is 0, 1, and that's how we got this point 0, 1. Alright, let's suppose if you have y is equals to e to the power x plus 2, let's suppose, right? So the graph will do the same behavior. The difference is now this point, it won't be 0, 1, right? When you place x 0, so 0 plus 2, it will be 2 only, and e to the power 2, that will be a value, that is a constant value that you will get on the y-axis. So you can say that at x is equals to 0, y is equals to e to the power 2. You can find out the value of e to the power 2 by using your calculator, and let me tell you the value of e to the power 2. So it's approximately 7.3, 7.4, whatever the value is. So that point will always be y-intercept. Alright, so that's how we are going to plot the graphs of y is equals to e to the power x. So first we need to write down these two examples in your copy, and whenever we need to draw the graph of exponential function, it will always be a curve that will never ever meet the x-axis. First you need to draw these two examples, and then I will explain further more examples. So you have a time of 60 seconds, so start. Alright, now let me take one more example, and now in this example I'll say that y is equals to e to the power x plus 2. Alright, so how we are going to construct this graph, listen to me very carefully because that is very important. Let me draw the roughly grid here. That is my x-axis, that is my y-axis, it's my origin, right? At first I'm going to highlight the point 2 here. So this point is 2 and I will draw the line here 2. And there is a reason that I am drawing this line with a red pen, because I need your attention towards this line, right? Alright. So when x is 0, you will get y is equals to e to the power 0 leads to 1. So you will get y is equals to 1 plus 2 and it will be equals to 3. So you got one of the point, it's 0 comma 3. That means when x is 0, y is 3, and this is your point, right? So in this case the graph will be like this. It passes through the green point and then follows the same behavior which we had discussed in the above two examples. So that's how my curve looks like. Now in this scenario, the line y is equals to 2, this one, it will act as an asymptote that my graph will never ever cut the red line. Alright, whatever number is written is here, let's suppose e to the power x plus 5, e to the power x plus 10, whatever the number is, that line will be act as an asymptote that my graph will never ever cut this line. Alright, so that is an important thing you need to remember, because in your past papers whenever we attempt the question from the topic functions, this concept helps me there as well. So try to note down all the things which I've told you on the screen, and for the last thing that you need to note it down, you have a time of 40 seconds. Alright, so note it down, and then I will heading towards the book question. So start. Alright, so that is the basic introduction regarding the exponential function graph, that the behavior of exponential function, right? And it will never ever cut the x-axis, or the value you have in the question, it will never ever cut this value, right? So that is a normal procedure or normal thing of the exponential graph. So that is your exercise 19.1. Let me write it, 19.1. It's question number 2. So it says that draw the graph of y is equals to e to the power 2x. Alright, we need to draw the graph of y is equals to e to the power 2x for 0 till 2. So you have the values of x, it's from 0 until 2. Taking intervals of 0.5, that means if I construct the table here to find out the values, so x and y, so x starts with 0 and then 0.5 and then 1 and then 1.5 and then last is 2. So that is meant by interval 0.5 by drawing a straight line. Alright, that is my first part. Alright, I need to draw the graph of e to the power 2x on this grid, and firstly I need to find out the values here, 0, 0.5, 1, 1.52. So you have a time of 60 seconds, and what you need to do, you have a value of y is equals to e to the power x, right? So for first value, when e is 0, so I will say that y is equals to, sorry, x is 0, it's e to the power x is 0, right? And it will be equals to 1. So I got my first value, that is 1. Alright, so you have a time of 60 seconds. I think it's enough to complete this table, find out the values of y. In fact, take 90 seconds, because maybe you will need more time. So you have a time of 90 seconds to complete this table, and then I will start with the construction of graph. Alright, so these are the values I hope that you are getting. Make sure that it's e to the power 2x. Previously I have written only e to the power x. So these are the values I got here. I hope that you are getting the same values, and now I will construct the points here. So firstly, it's my grid. There is no scale on the question, so I will take the scale according to the data. Make sure that you are going to plot the curve on your graph paper. I'm just drawing it roughly here. That is quite difficult for me to draw the graph here. So it's x and y. Values on the x-axis starting from 0 till 2. So I will take 0, 0 0.5, 1, 1.5 to this. On my x-axis it's acceptable. 0, 0 0.5, 1, 1.5 and 2. Right? These are my x-axis values. From my y-axis I got the lowest value, it's 1. Alright, and the highest value it's 54.6. So if I say that 5, 10, 15, 20, 25, 30, 35, no. So what I will do, I need to take 10, 20, 30, 40, 50, yes. And I think it will be good. 10, 20, 30, 40, 50 and 60. Right, make sure that you are drawing it on the graph paper. And now I'm going to plot the points here. So I'm using green pen to plot the points. So at 0 it's 1, so it will be like here. Alright, 0 and 1. When it's 0.5, so it's 2.7. so that means the first box, this one. Alright, when it's 1, so it's 7.4, so 2, 4, 6, 8, 7.4. And when it's 1.5, so it's 20. 1.5, it's 20. Trust me, it's very difficult to plot the curve here. Alright, and when it's 2, so it's 54.6, so 50, 2, 4 and this one. Alright, so I got all the points here, and now I need to construct them with a curve here. So that's how my e to the power 2x graph looks like. Alright, so make sure that you are doing it on a graph paper, and your graph should be look a lot better than what I had drawn here, but it follows the same pattern. The same curve should be on the graph paper with same values, right? And you need to draw it with the scale pencil. No need to use pen here. Alright, so once you had drawn the graph, after this part it says by drawing, I hope that you had drawn it, and if you need some time, so I will give you 1 minute to construct the graph here, and then I will start with the next one. So start. Alright, so I hope that all of you have drawn the curve. After that it says, by drawing the straight line y equals to 5 minus 2x on the same graph, obtain an approximate solution to the equation e to. Alright, so firstly what we need to do, we need to draw the curve of y is equals to 5 minus 2x, right? And how you are going to draw that line, it's very simple. You need to make a table like we had done in the previous part. This one, first is x and then y, right? And now you need to assign different values of x. So I will pick, because it's a straight line, so I need only one or two values at minimum. So I will pick 0, 1 and 2. Alright, and then I will find out the values of y here, and then I will construct the line here. So firstly, what you need to do, you need to fill out the table here, right? And then you need to construct the line of x and y here. So you have a time of 90 seconds to complete this part, and then I will tell you the answer. So start. Alright, so I hope that you are getting the same values, and now I will plot the points here. So when x is 0, y is 5. So when x is 0, y is 5, 2, 4 and 5. I'm using red pen to highlight the coordinates of this line here. Alright, after that, when x is 1, y is 3. So when x is 1, y is 3, so 2 and this point here is 3. And when x is 2, y is 1. So x is equals to 2, y is equals to 1. This one. Alright, so I need to draw these 3 points here. Alright, so I tried my best to draw the straight line, as you can see, by plotting all those points. And I expect that your line should be similar to this one, like I drawn here. And after this line, it says obtain an approximate solution to the equation, and the equation is given. It says that e to the power 2x is equals to 5 minus 2x. Now if you observe the equation, and if you observe the two graphs that we had constructed, is there any relationship that you can observe in the last equation, that is e to the power 2x is equals to 5 minus 2x? Anything that is common that you can observe here? Alright, so if you see that the two equations we have plotted, the first one is e to the power 2x and the next one is 5 minus 2x. Basically in this equation these two are equated, right? These two are equated. So basically I need to highlight the point of intersection of these two curves. This means this one. So it might be possible that your values might be different from what I'm getting here, because I'm just roughly drawn it. But if I observe, so it will be at first I need to find out the scale on my x-axis, right? So on my x-axis it's 0.1, 2, 3, 4, 5. Two small boxes on x-axis. Two small boxes is equals to 0.1 unit. Alright, so with this scale I say that it's 0.5, so it's 0.6, it's 0.7. The value I am getting here is 0.7, and the chances are pretty well that you are getting some different value, right? But it must be close to 0.7. If I'm getting 0.7, maybe you are getting 0.75, 0.65, but it won't be like that way that you are getting 0.2 or 1.5, so that will be wrong, right? So the reason that the values are differing, your answer or my answer, is because I have constructed the roughly, right? I have plotted the roughly curve, because I'm not the resources are not available that I can draw exactly graph exactly curve on this note one note software. So make sure that you are plotting it on the graph paper, so you will get the accurate answer. Alright, so that is the first part, and now what we have learned how to draw the exponential curve, right? And the concept of asymptotes we have learned in the explanation part. Moving on towards the next question. It's question number 5. Sketch on separate diagrams the graph of the following exponential functions for the given intervals and state the coordinates of the points where the graph cross the y-axis. All right. So in the 4-part question, what we are going to attempt part B and part C. All right. So on my left side of the curve axis, I will do part B, and here I will attempt part C. So in part B, the equation we have, it's y is equals to e to the power minus 1 over 2x, and the values of x I got here is minus 2x and 1. Alright, so there is no such point given that the interval should be 0.5 or interval should be 1. But if you construct the table here, so it's x and y. So firstly I will pick minus 2, after that I will pick minus 1, after that it's 0, and the last one it's 1. Alright, so these are the 4 values, and I will place each individual value in the equation y is equals to e to the power minus 1 over 2x to complete the table. So first you need to complete the table, and for that part you have a time of 90 seconds, so start. Alright, so these are the values I am getting here. I hope that you are getting the same values. So now we need to construct it. In this scenario, I need the space for negative x-axis. So I will draw my axis in the center. Alright, but there is no need to draw the negative y-axis. So that is how my grid looks like, right? So firstly it will be minus 2, minus 1, 0, 1 and 2. Alright, and after that I need to plot the values on the y-axis. So I can observe that the highest value I'm getting on the y-axis, it's 2.7. Alright, so I will draw the graph 1, 2 and 3. Make sure that your 70% of the graph should be occupied. That should be the proper way to draw the graph. Alright, now after the grid I need to plot the points, and these points I will construct with a green pen. So when x is minus 0.2, y is 2.7. So minus 0.2 and 2.567, this one. That is my first point. When x is minus 1, y is 1.6, that is my second point. When x is 0, y is 1 third point, and when x is 1, y is 0.6, that is my fourth point, right? So if I construct those 4 points, the curve should be like this, and we know that it proceed in this way, that it will never ever cut the x-axis. So that's how your exponential graph of e to the power minus 1 upon 2x looks like, and you need to complete that question in your graph paper copy as well. Alright, so make sure that you need to construct the curve as smooth as you can. Alright class, so you have a time of 2 minutes to complete the curve in your graph paper, and then we will heading towards the part C. So first complete it, start. Alright, now in part C, the question says, uh, part C, question is y is equals to e to the power minus x plus 2, and you have the values of x given, so I'm just instructing the table here, x and y. So the value of x is minus 2 to 2, so minus 2, minus 1, 0, 1 and 2. Alright, so firstly what we need to do, you need to complete the table, and you need to complete the graph as well. You need to complete the whole question, and then I will tell you the correct graph. So for this part you have a time of 4 minutes, so start. Alright, so I have completed the table here. You can verify your values firstly, and then I have constructed all the points here which I got in the table, and now I will construct those points with a smooth curve, so it will be in this way. That's how you curve. It should not meet the 2 value, so because that will be an asymptote. So that's how your curve looks like of y is equals to e to the power minus x plus 2, right? And we can extend the graph here. So that's how your curve looks like. Alright, so I hope that now you have an idea how to construct the exponential curve, right? It's very simple, like we draw some other graphs by substituting the values of x and find the values of y, similar to the exponential functions. And after that, moving towards the next question, is question number 7. Given that y is equals to 4 to the power x minus 1, find the value of y when x is equals to 0. Alright, so what is the value of y? It will be y is equals to 4. The value of x is 0 in the first part, so x is 0, so it's 0 minus 1. So you can say that y is equals to 4 to the power minus 1, and if we simplify, so it will be y is equals to 1 to the power 1 upon 4. Alright, so for part B, it says value of x when y is 8. So we have y is equals to 4 to the power x minus 1. Y is 8, so it will be 8 is equals to 4 to the power x minus 1. So what is 8 basically? 8 is 2 power cube, and what is 2 basically? 2 is 2 power 2 and the whole power x minus 1 as it is. So if we equate the powers, it will be 3 is equals to 2x minus 2, and 3 plus 2, it's 5 is equals to 2x, and x is equals to 5 divided by 2. That is your part B answer. That concept of same power is from the topic indices, which we have learned in the previous classes as well in mathematics. So first we need to write down these two parts, and then I will explain you what about the sketching. So you have a time of 90 seconds, so start. Alright, so now I have the graph paper here. So firstly I will draw the axis. It says sketch, right? Now you can observe that there is no range of values that it was given in the previous question. So it says sketch, that means now we need to draw the curve with the concept of how we draw the exponential curve, right? But if you observe that in part A, it says when x is 0, so basically we got our first coordinate point. When x is 0, y is 1 upon 4, that is my first point. And in part B, when y is 8, so x is 5 upon 2, so that is my second coordinate, right? So I got two coordinates here. The function we are going to plot is y is equals to 4 to the power x minus 1. It will be same as we draw the exponential curve. So we know that when x is 0, y is 1 upon 4. So let me just draw the values here. So these are the 2 points I am getting here. When x is 0, y is 1 upon 4. 1 upon 4 is 0.25. And when x is 2.5, that is 5 upon 2. So y is 8, right? So I am getting these 2 points here. And in between 0 and 2, let's suppose if I say that x is 1.5. If I place x is 1.5, y is 2 here. So now I know the pattern of how to draw these graphs, so that's how it looks like. And that is the roughly sketching of the curve y is equals to 4 to the power x minus 1, right? So whenever we have variable in powers, so that will be same strategy as we plot the graph of exponential function. Alright, so I think that it is quite enough for today class. I hope that now you have an idea how to construct the graph of exponential functions. Make sure to complete your homework, submit it on time, and in the next class we are going to continue some of more questions. So see you next